Hi, and welcome to a complete course in using algebra tiles. Today we are going to see how we can use algebra tiles to group like terms, expand by the distributive law, solve simple equations, multiply polynomials, factorize quadratic expressions, complete the squares, and solve quadratic equations. Let us start with the basic characteristics of the tile. This is the x squared tile. It is the larger of the two square tiles in the set of algebra tiles. And this is the x tile. It is a rectangular tile and it has the length that is exactly equal to the sides of the x squared tile. And this is the unit tile. It is the smaller of the two square tiles and it has the sides that are equal to the width of the rectangular tiles. Let us line them up together. The flip side of the x squared tile is red. This represents negative x squared. The flip side of the x tile is negative x. And the flip side of the unit tile is negative 1. One important element that you must remember is that when the x squared tile comes together with the negative x squared tile and the x tile comes together with the negative x tile and the unit tile comes together with the negative unit, they are all equivalent to 0. This is practical because x squared minus x squared is 0, x minus x is 0, and 1 minus 1 is 0. But this is a very important element to use the algebra tile. We will discuss this later. Let us simplify this expression. To simplify this expression, we need to model the expression using our algebra tiles. So, we see 2x squared. This means that we're going to use 2 of the x squared tiles. Minus x means we are going to use 1 of the rectangular tile on the flip side, that is the red side. Positive 5 means we are going to use 5 of the unit tiles. Minus x squared means we are going to use 1 of the larger square tile on the flip side. Positive 3x means we are going to use 3 of the rectangular tiles on the positive side. Minus 2 means we are going to use 2 of the unit tiles but on the flip side. Now that we have modeled the expression, what is left to do is to group all the tiles that are of similar shape and sizes together. Keep in mind the nullifying effect of x squared minus x squared, 1 minus 1, and x minus x. In other words, x squared cancels with minus x squared, minus 1 cancels with 1, and x cancels with minus x. When these tiles are nullified, we will be left with these set of tiles. When we model these set of tiles, this is equivalent to x squared plus 3 plus 2x. But this is equal to x squared plus 2x plus 3. This is our answer. So when 2x squared minus x plus 5 minus x squared plus 3x minus 2 is simplified, you have x squared plus 2x plus 3. Let us assume that we were given this to expand. To expand by the distributive law, here you need to model this expression. But let's first conceptualize 3 into 2x minus 1. This is the same as saying 3 sets of 2x minus 1. So if I were to represent 2x minus 1 using our algebra tiles, it would look like this. 3 sets of this 2x minus 1 would look like this. So 3 into 2x minus 1 is modeled by these algebra tiles. Let us group the tiles together according to their size and sheets. After our rearrangement, we can clearly see that when we have 3 sets of 2x minus 1, this is equivalent to 6x minus 3. So that when we expand 3 into 2x minus 1 by the distributive law, this is equivalent to 6x minus 3. Let us suppose you had this simple equation to solve. To solve this equation using algebra tiles, you need to model this equation. X plus 3 is represented by one of the x tiles plus 3 of the unit tiles, like this. And this is equal to minus 2. This means we are going to use 2 of the flip side of the unit tiles. The idea in solving a simple equation is to isolate x or keep x on one side of the equation. In this case, we are going to keep it on the left-hand side. To isolate x, we are going to add 3 of the negative tiles so that we can nullify these tiles or make them 0 pairs. This is done like this. But because we added 3 of the negative tiles on the left-hand side, we need to also add 3 of the negative tiles on the right-hand side to maintain the balance. Now that the balance is maintained, keep in mind the unit tiles on the left-hand side were nullified or they were 0 pairs, so they are eliminated. We are thus left with x equals negative 5. This therefore is our answer. Suppose if we had another equation, 3x plus 5 equals minus 4. This can also be represented using our algebra tiles, using 3 of the x tiles and 5 of the unit tiles. And this would be equal to negative 4, or 4 of the flip side of the unit tiles. The idea again is to isolate x. So what we need to do is to remove the 5 unit tiles on the left hand side. This is done by using our 0 pairs or our nullifiers, like this. And because we added 5 negative unit tiles on the left hand side, we need to add 5 negative unit tiles on the right hand side. Remember, the tiles that were added on the left hand side are nullifiers. In other words, they are 0 pairs. So this is eliminated. Now it's difficult to see our answer in this form. So what we do, since there are 3 x's on the left hand side, we pair the unit tiles off in groups of 3. Let us do a rearrangement. So now that we have rearranged the tiles, we can see that each of the x tile is equal to negative 3. This tells us our answer, x is equal to negative 3. Let us suppose we had to expand this binomial x plus 1 into x plus 2. To do this, we need to model the expression. And to model the expression, we are going to use our multiplication table. Here is where we're going to put the x plus 1. But note that x plus 2 consists of x plus 1 plus 1. We need to fragment the expression in order to do the multiplication using our algebra tiles. You also need to keep in mind that the x squared tile has the dimension x units by x units. The x tile has the dimension x units by 1 unit, and the unit tile has the dimension 1 unit by 1 unit. It is also helpful to note that whenever you are multiplying a negative number, it is the same as the flip side of the tile. We will get to this a little later. Now we are going to multiply the x times the x. X times the x can be interpreted as a tile that has x unit length by x unit length. And the tile that fits that description is the x squared tiles. Now we are going to multiply the x times the 1. This can be interpreted as a tile that has x unit length and 1 unit width. The tile that fits this description is the x tiles. Similarly, when I multiply x times 1, I will get x. Now we are going to multiply the 1 by everything else. 1 times the x means you are looking for a tile that is 1 unit in width but length is x units. That suits the description of the x tiles. Note that the x tile here is placed horizontally. This is because when you are multiplying the other nomials, the orientation of the tile changes. Now when we are multiplying 1 by 1, this is interpreted as a unit tile, since a unit tile has dimension 1 unit by 1 unit. This is interpreted as a tile that has a side of 1 unit squared, and the tile that fits that description is the unit tiles. Now if we sum all the tiles that are under the multiplication table, that will give us the product of x plus 1 into x plus 2. We have x squared plus x plus x plus x plus 1 plus 1. This will give me x squared plus 3x plus 2. So that the product of x plus 1 into x plus 2 is equal to x squared plus 3x plus 2. Let us look at another example. Suppose if we had this to simplify. Here is our multiplication table. This time I'm going to put the 2x plus 1 on this side. 2x plus 1, remember, must be fragmented so that we'd have x plus 1. This is equivalent to 2x plus 1. And on the other side, I'm going to put x minus 3. Remember, this also must be fragmented so that I would have x minus 1 minus 1 minus 1. The first thing I'm going to do, I'm looking for a tile that has a dimension x by x, and that is the x squared tile. X by x, another x squared tile. X by 1, that is the x tile. The dimension minus 1 by x, remember, should be interpreted as the flip side of the x tile. And what is the flip side of the x tile? The negative x tile. The flip side of the other x tile is negative x. The flip side of 1 is negative 1. This is repeated. And so the product of 2x plus 1 into x minus 3 would be the sum total of all the tiles that are beneath the multiplication table. But be careful. Look carefully and you will see that some nullification or a zero pair occurs. This occurs when we have an x and a minus x, and therefore these will be eliminated. Now we can actually count the amount of tiles beneath the multiplication table to get our answer. Our answer therefore will be 2x squared minus 5x minus 3. Let us suppose we had this quadratic expression to factorize. Keep in mind that factorization is the opposite process of multiplication of polynomials. Hence, we can use the multiplication table again to help us factorize. The next thing we do is to model x squared plus 5x plus 6. The x squared tile always goes in the corner of the multiplication table like this. In factorization, the aim is to try to create a perfect rectangle. To do this, we can distribute 3 of the x's longitudinal like this and 2 of the x's horizontal like this. There is a void that is here, and this void can be filled with the 6 unit tiles that is needed like this. This expression so happens to be able to completely factorize quite easily. Here we can see the length is x plus 3 unit long and the width is x plus 2 unit wide. Hence, when we factorize x squared plus 5x plus 6, this will give me x plus 2 into x plus 3. Suppose if we had another expression like this. Here is our multiplication table. Again, we are going to model x squared minus x plus 2. The x squared goes in the corner. Minus x can go either side, but I will put the minus x at this point. Now we have minus 2 units. This means that 2 units are going to go to the bottom diagonal of the x squared tile. Note that the unit tiles always go to the bottom diagonal point or diagonal vertex of the x squared tile, like this. But if you observe, there are missing elements in this rectangle. There is a tile that is missing here and here. How can we fix this? I'm sure you could recall us discussing 0 pairs tiles, because if we add 0 to this expression, we will get back the same expression. Similarly, if I had x minus x, this will give me 0. So our expression would still maintain the same. However, doing this will enable me to complete my rectangle like this. And now that our rectangle is completed, we can factorize. Our factorization will be of length x minus 2 and x plus 1. So our answer should be x minus 2 into x plus 1. Completing the squares using algebra tiles is done quite easily. This is because we actually create a square using elements from the expression. Let me show you what I mean. If this is your multiplication table, we are going to try to model a square using the expression that is given. Here is where the x squared goes. Since we are trying to create a square, this means that I can distribute the 4x by putting 2 x's up on this side and 2 x's down on this side. Keep in mind, it's a square we are trying to create. But we have one more unit in the expression. But there's a void. There's a void of 4 positive unit tiles to complete this square. So what do we do? Well, keep in mind that we always have the tool called zero pairs or your nullifiers. We need 4 zero pairs so that it can assist us in completing the squares. So if this is 4 positive tiles and this is 4 negative tiles, this is equivalent to saying 0, so that the expression doesn't change. We can now place the 4 unit tiles here so that we can complete the squares. But note that we have remaining 4 negative unit tiles and 1 positive unit tile. Remember, the negative and the positive cancel out each other because they are zero pairs. So we are left with this. This is our completed squares. The side of the completed square is x plus 2 units. So this side is x plus 2 units. And this goes under the square because the square is x plus 2 units by x plus 2 units. Keep in mind that we have 3 negative tiles that are left over. So this 3 negative tiles goes here. This is equal to -3. So when we complete the squares, x squared plus 4x plus 1, this is equivalent to the square of x plus 2 minus 3. This form is also called vertex form. Let us look at another example. Suppose you were given this. Most examining body asks you to write this quadratic expression in this form. In other words, they are asking you to complete the squares or write in vertex form. To do this, we use the same process. Here is our multiplication table. Now we are going to model x squared minus 4x plus 1. Our x squared goes here. We are going to distribute the minus 4x by putting minus 2x up on this side and minus 2x down on this side. We also were given 1 positive unit tile. Note that you need 4 negative unit tiles to complete the square, like this. But remember, if I add 4 negative unit tiles, that would change the expression. Hence, we need the 0 pairs for these 4 negative tiles. Now we have 0. Now the expression does not change. To complete the squares, therefore, I am going to put the 4 negative tiles in the space provided. Now we have a completed square. So, our answer for completing this square will be the square of x minus 2 plus 5. By now you would have recognized that you can solve quadratic equations using complete factorization. We have completely factorized quadratic expression before using algebra tiles, and we recognize that in completely factorizing, you would have ended up with 2 simple equations, and we can solve these 2 simple equations using our algebra tile. However, what if you were given the quadratic equation in vertex form like this? Then you will need to create 0 pairs tiles that is equivalent to minus 9. And when you do that, you would have this expression. The square of x minus 2 equals 9. This means that if I model the square of x minus 2 on the left hand side, it would be a square that consists of an x squared tile plus 2 negative x tiles on either side. But note that the square is incomplete unless you have these 4 negative unit tiles, like this. Now we have a perfect square. This is equivalent to 9 unit tiles. We also arrange the 9 unit tiles in the form of a square. We have almost met to our answer. This side of the square represents x minus 2. So we say x minus 2 is equivalent to the side of the square on the right hand side. That is here. And this is equal to 3 units. When we model this simple equation, we will have this. Would mean that we have to put 2 unit tiles on the right hand side also. These 0 tiles disappears like this, so that we are left with x equal to 5. Keep in mind that a minus times a minus is also equal to a plus, or the opposite of a unit tile is a positive unit tile. This means that x can also be minus 5. This is the end of the video. Thanks for watching. Please don't forget to like, share, and subscribe.